We're going to be learning Rust on Fridays. So if you want to learn Rust, pop by on Fridays at 5 p.m. UTC. What I did was I created a repository on my GitHub called Rust is a Must. It just rhymed and it sounded cool. We're going to be going along through this Microsoft course called Take Your First Steps with Rust. There's several modules in here. We're going to start off with this course. Other folks have mentioned doing Rustlings as well as the official book. I'm thinking of doing those things after. I'm going to learn it because it's part of WASM WebAssembly. Not part of, but you can write WebAssembly using Rust. And that's, fits into my web development tool belt. That was my initial reasons for learning it. It can be used for the command line. You can make applications with it outside of WebAssembly. I think parts of the Linux kernel are starting to be ported from C and C++ to Rust. There's lots of use cases and it seems to be getting more and more popular. Here's the first part, I believe. Let's go back to take your first steps. Here's the module learning path. Hello world is typically the way you go when you start learning stuff. Let's see what Rust is all about. It's type safe for folks in web development world. If you've done TypeScript, that brings type safety to your JavaScript, but other languages like Java, C# also have this. I did C# up until 2016. It's memory safe. It's saying Rust pointers, known as references, always refer to valid memory. Unlike something like Java or C#, which have garbage collection, you don't have to worry about the memory. In Rust, you have to. In like C or C++, you have to manage the memory, but it's saying that if you have these pointers in Rust, they will always point to valid memory. It sounds like you're still managing memory, but when you do allocate it, you seem to be guaranteed it's going to be data erase free. Rust borrow checker guarantees thread safety by ensuring multiple parts of a program can't mutate the same value at the same time. I'm gonna paraphrase, probably just means you'll never end up in any race conditions when modifying data. How it does that, I'm not sure. Maybe we'll dive deeper into the borrow checker at some point. Zero cost abstractions. Rust allows us to use high-level concepts like iteration, interfaces, and functional programming with minimal to no performance costs. The abstractions perform just as well if you had written the underlying code by hand. Minimal runtime. Rust has a very minimal and optional runtime. The language also has no garbage collector. Like I was saying before, something like C# or Java, they do have garbage collection because they manage the memory for you. It's saying Rust is most similar to languages like C and C++, where you have to manage the memory. Targets bare metal. Rust can target embedded and bare metal programming, making it suitable to write operating system kernel or device drivers. That gets back to what I was saying. I forget where I read it, or it was a tweet. Part of the Linux kernel starting to use Rust. Let's install Rust. I'm gonna do I copy this? All right, so curl proto. All right, so let's go curl. I do have the command already, but I am gonna run it again. Proceed with installation. Yes. So we installed Rust. Now we're going to verify the versions are installed. So let's go back. It's going to write cargo version. Let's move on to the hello world here. Okay. We've installed Rust. We checked the versions. It's all good. I created a project. This is what we're going to work out of. And I did do this first a little bit. So I'll just show it anyways. But main RS, let's close that. This is similar to like if you've done C# or Java, there's like a static main, or I think in C# it's been a while, but public static main. And this will just run hello world. If you do Rust C, I believe is what they're going to tell us. Yeah, so we run rustc and then the name of the file, main.rs. Main.rs is what I created a couple days ago. If you want to compile this, there's the Rust compiler, which is rustc, and we have our main file here called main.rs. I'm going to run that. What that does is if we come back here, it creates a main file. It's a binary, so it's not going to display it. Now if I just run main hello world, we have things working now. What is cargo? While the Rust compiler is fine for simple programs, almost no projects use the Rust compiler directly. Instead, they use Rust build tool and dependency manager cargo. This is similar to, I imagine, npm or yarn for adding, removing dependencies. I guess it's a combo. That's for getting the dependencies, but I guess it compiles too. I'm not sure. Let's find out. The good news is that when you install Rust up, you also get the latest stable version of cargo. Cargo does a lot of things for you, including, okay, so I won't read it all out loud. Templates, project, run a project. Yeah, it does seem like npm or yarn where he's saying, run a script, do this. You can, run ESLint, I guess. Cargo doc, generate your docs. It's not one-to-one, but it's similar. Like if you're coming from, Node.js or front end world, and then you can publish them. That's where that other VS Code extension was coming from in terms of using the website crates.io. That's where you can publish it, which is kind of like the npmjs.org site. Unit, exercise, hello world. Start using cargo, make a new project. Make sure your terminal is at your Rust learning path directory and run the following command. I don't have the Rust learning path, but I'm going to create this new one here, cargo, new hello cargo. We're back to where we were. Okay, that's good. I don't need to commit the main there. Okay, so GCI, initial commit. These are all git aliases. This means reset hard head. I'm going to just wipe out the main for now because I don't think we need it. I'm going to do a git push force, and that's going to update the repo. Because I have aliases, I can explain what the alias is for. We are in our project now. I'm going to call cargo new hello cargo. So let's see what that does. We're going to run cargo new hello cargo. It said created binary application hello cargo package. This generates a new directory called hello cargo with the following files. Cargo toml source main.rs. I guess template structure or folder structure, sure. Cargo toml is the manifest file for Rust. If you're coming from web dev world, package.json, same idea. It's where you keep metadata for your projects as well as dependencies. Source main.rs is where you'll write your application code. You can see the cargo new generated a boilerplate hello world project for us. Cool. I'm gonna commit as we go along. So GA is my alias. G is my alias for git. Yes, I'm lazy. And A is for add all. So I'm gonna say git commit ran. There we go. Cool. And give that. There's that print hello world we had. Now we're good there. Build and run your program with cargo. To run this program, move into the new directory hello cargo and run this from the terminal. So cd hello cargo and then cargo run. All right, so it compiles it and it looks like it ran the main and it outputted hello world, which makes sense. Congratulations, you've just learned how to initialize your first Rust project with cargo. Boom. Understand common concepts in Rust. We haven't done a whole lot yet, but that's not a big deal at all. Let's learn the basics of Rust, variables, data types, structs, enums, functions, indexing, hash maps, and flow control. We use the let statement to assign values to variables. I don't know if they took that from let from JavaScript or if that existed in other languages prior, but anyways, that's how we'll set variables. We'll learn how to comment the code to make it more descriptive, basic data types, write our own functions, use collections to store multiple values in a single structure, learn how to use conditional statements and loops in your code. All right, introduction. In this module, we're going to learn the concepts, programming language that we use in Rust. It's the Rust playground. Let's take a peek at that. This looks kind of like the TypeScript playground. This or any REPL. So it's a browser interface to the Rust compiler. We can mess around in there. They're going to provide us with links to the playground, which is nice. Everything that runs in the playground should be able to run and compile and run locally. Let's use the let statement to assign variables and a few things here. Just basically repeating the same thing it said in the other one. All right, create and use variables. So fn is the way we write functions instead of function or func. Looks like in Rust, they use snake case. If you're coming from JavaScript, you're probably used to camel case, or Ruby, where it's kebab case, I believe, by default. Here in this main function, we're setting a number to 10, a Boolean to true, and then we're just printing them out with println, and it looks like when you use the squiggly brackets, or as Jason Linkstorf calls them, curly boys, that gets replaced by the variable over here. I find this interesting, the println macro. I'm wondering why it's a macro and not a function. I'm gonna guess maybe because it's got the exclamation mark there. I don't know what the macros are in here yet, though. We'll see. Oh, we won't cover Rust macros in this module. For now, you can think of println macro as a function with a variable number of arguments. We can go ahead and run this, I guess. Let's go to playground. I guess I need the call main. Maybe I don't call it directly. Let's run this. Maybe because it's called main, it just executes right away. That's why. I wonder if I called it YOLO and then I go YOLO. I don't know if it'll let me run that. Compiler playground error expected one of, I'll try it with the exclamation mark. Let's see. Macros that expand to items must be denoted braces as followed. On the plus side, I find the error messages pretty descriptive. Change the delimiters to curly brace. Unlike JavaScript, you actually need a semicolon. I find macro YOLO. You know what? Let's put it back to main. It works. We know that we were able to set variables. And let's do that again. So main will run, it'll print out number in the Boolean. Mutability. That means it can't be changed. If we try to change the value of our number from the previous example, we would receive an error message. I'm going to guess where they're going with this. By having things immutable by default, even if it might hurt your brain a bit at the start, it will potentially prevent less errors. We can't assign it twice. I can't say a number 15 here. Let's go ahead and run this directly and see. Oops, there. I'm expecting a compilation error. Cannot assign twice to immutable variable a number. Makes sense. This code compiles without errors because variable a number can now be mutated. If we add them, it's not mut, but mute. Let's do that to see. It's kind of nice that you have to explicitly say mutate, because then you're very conscious. Hey, I know what I'm doing here. Let me drive. Let's run that. That runs as expected because we can mutate it. We were in the playground. We saw those error messages. Shadowing. You can also declare a new variable with the same name as a previous variable, which creates a new binding. In Rust, this is called shadowing because the new variable shadows the previous. The old one still exists, but you can't refer to it in this scope anymore. Let's run this. So we're expecting it to print out 5. That's 10 times 2, 20. That should run. Give us 20. This is interesting because it looks a little weird to me, mainly because I'm used to other languages. I've never worked in a language where you can redefine it. If we put these print statements in here, I'm expecting to see 5, 10, 20 get outputted. That's expected. But I do find this interesting. I'm curious. I'm sure there's a reason you want to do this. Maybe when you start off in your function or your block of code, like in the curly boys. I can't stop saying that now because of Jason. Maybe you have a valid reason to change it up at that point. I don't know why you wouldn't just give the variable another name, but maybe there's a reason. Let's learn about data types now. It's statically typed. That means the compiler needs to know, so it can compile the program. Know exactly the data types for the variable in your code. In most cases, the compiler can infer type of some value and you don't need to tell it explicitly in your code. That makes sense for primitive types in Rust too, like a Boolean, number, etc. Let's see what it says here. Suppose we're writing a program to convert a string to a number and uses the parse method to do so. Let number u32, which is an int32 number, I'm guessing. We're going to say 42.parse expect not a number. That's interesting, the dot expect right in the code, like it's testing it as you parse it. In this example, we tell the compiler that we want the number variable to be a 32-bit number, u32. We can experiment by removing the type annotation to provoke and observe a compiler error. Let's do both here. We'll put this in main because that seems to be the easiest way to run things right now. I don't know how to actually invoke a function yet because all the things I tried didn't work. We'll get to that. It's going to run this. Apparently this should work because we've explicitly set the variable type to a 32-bit integer, so it knows when it parses the string 42 that it will return the number 42. And we shouldn't get that error, expect not a number. Interesting. Warning. Let's do this. Let's do print ln number parsed was, and then the curly boys. I'm kind of having fun saying that now. I need to put number here. If we run that, it should say number parsed was 42. Let's see what it's saying here. If I don't explicitly set the type here, it should give that error. Let's see what happens there. Type annotations needed. Consider giving number a type. Now, I get the explicitly setting it because you know what it needs to be. I would have assumed, though, that this parse method parses to the type 32-bit integer, which is U32. I'm actually not sure why I have to explicitly set it. I wonder if, okay, that is how you comment things. I wonder if I take that expect out and then run it. I'm going off script here a little bit. I just want to see. Cannot be formatted with a default formatter. I'm still not sure why you need the U32 in that case, but maybe it's because if you parse a string, it can, maybe it's because you can parse it to different things actually. Maybe you wanted to parse it to U64. I'm assuming that exists. If I run that, it should give me 42 still. That's what it is. It doesn't know if I want a 32-bit integer, a 32-bit integer, or a 64-bit integer. Now it makes sense. It's because the parse, it can return either. All right. We tell the number, we tell the compiler we want the variable number to be a 32-bit number. We can experiment. Yes, we got that error. Rust built-in data types. We got numbers. There's 8 bits, 16, 32, 64, 128. I don't even know what an arch number is, but I'm assuming it's a big ass number. Additionally, isize and usize types depend on the kind of computer your program is running on. 64 bits if you're on 64-bit architecture, 32-bit 32. The default type is F64 because on modern CPUs, it's roughly the same speed as floating point 32, but it's capable of more precision. All the primitive number types support mathematical operations. 1 plus 2 equals. And then I guess you can specify that a number is 32-bit by adding it, post-fixing it to a number. So this should give 3, this should give -1, this should give 9 divided by 2, that's 4.5, and so on and so on. Let's run all that. It's nothing to commit to our repo at the moment, which is totally fine. Maybe most of the stuff's done in the playground. We'll see. Like it's saying, looks good. Nothing super out of the ordinary here. So they're using suffixes on the literal numbers to tell Rust which data type they will be. And if we don't provide the type annotations, Rust tries to infer. That makes sense. The type from context defaulting to 32 when it's ambiguous. I'm sure these things will come into play later on. Booleans in Rust are represented by the type bool and have 2 possible values, true, false. I'd be kind of scared if a Boolean had more than 2 values. Used in conditionals, let is bigger, 1 greater than 4. It's going to give us false and print false. Even if some of these look obvious, I'm just going to run them through the playground anyway. I'm curious. I feel like this playground is probably using WebAssembly, which is probably built with Rust, because I don't imagine this playground is serving everybody at the same time. Not the web page, but like when it compiles. Let's run this and it should say false. Everything pretty much expected right now. That's good. Characters and strings. Rust has 2 string types and 1 character type. They're all UTF. Char type is the most primitive, and you need to use single quotes. In JavaScript, it doesn't matter, but I think when I was doing Java a bit in university, and I'm almost certain in C# you had to use single quotes for characters, but I can't remember. They call it str. Also known as a string slice, is a view into string data. Most of the time, we refer to those types in reference form by using the form &str. This is where we start dealing with pointers. I did C++ in university many moons ago, but that's how you would get the reference from what I remember. We'll cover references in the following modules. For now, you can think of str as a pointer to an immutable string data. Although string literals are convenient, they aren't suitable for every situation where you want to use text, because every string cannot be known at compile time. I guess that makes sense. If you're getting info from the terminal, so you're reading in stuff. For those situations, Rust uses a string type called string, gets allocated on the heap. It goes on the heap because they don't know what the size of it is going to be at compilation times. It could be one character, it could be like a paragraph. If you're coming from a garbage collected language like Java or C#, you're wondering why Rust has two string types. Spoiler alert, it actually has more. Oh noes. I'm sure there's good reasons though. Turns out strings are extremely complex data types. Most languages use their garbage collectors to gloss over this complexity, but Rust, being a systems language, exposes some of the inherent complexity of strings to you. That's the classic Spider-Man's uncle. With great power comes great responsibility. With this added complexity comes a very fine-grained amount of control over how memory is used in your program. That makes sense because if you're writing like kernel level code, you would probably want to be able to have very fine-grained control over these things. Get a full idea until we learn about Rust's ownership and borrowing system. I am curious about those because I keep hearing about Rust's borrow checker, and I haven't read up on that yet. What's saying here? You can create a string from a literal by using the from function like so. Think of this as kind of like reading in hello, and then it's allocating 7 characters in a variable, and it's mutable. Then we can modify it so we can push a W to it, and then ORLD, we can push a string, just different methods. Then when you output it, it should say hello world. Let's go run that. Let's put that in main. Let's run that. We should see hello world exclamation mark. We tried running that in the Rust playground. Now we're talking about tuples. Tuples is a grouping of values of different types collected into one compound. They have fixed length, meaning that after they're declared, they can grow or shrink in size. The type of tuple is defined by the sequence of each member's type. Here's a tuple of length 3. We've got a string hello, a integer 5, and a character C. This tuple has the type signature ampersand apostrophe static str I32 char. Okay, I get the last two there, the I32 and char. So let's dig into the hello. The hello is in double quotes, so it's not a character. Let's figure out here. It's static, meaning, what was the str type again if we go back up here? Str type is a string slice. It's a view into string data. Most of the time, those types are referenced by using ampersand str. String literals are also typed str. That part makes sense. I'm trying to understand the static part. I guess it means because well, it's not immutable, but I'm wondering what they mean by static in this context. Tuples can be accessed by position, which is known as tuple indexing. Looks like you can treat it kind of like you grab it by the index in there, the zeros, the hello, etc. Let's go run that in the playground. So it's just asserting it. I'm gonna guess it's not equals if you do this, and this should blow up when we run it. It should say they are equal. I would have assumed any Q would have been it. I'm going off script here, so I'll just let it run like that. This is saying tuple should equal hello. Tuple at position 0, 1, and 2, so hello, 5, and C. I don't know about the string if that's considered a primitive type or not yet, but the 5 and the C, when you do the equals, it's the values, I'm guessing. That's why it's working. Anyways, we'll keep moving on here. Yeah, it just verifies if they're equal to each other, the assert equals macro, structs, and enums. Struct is a type that's composed of other types like tuples. A piece of a struct can be different types, but you can name each piece of data so it's clear what the value means. A struct, it has some properties and you can say what types they are. This does look like an interface in TypeScript if you've done TypeScript, or even in C#, but it's not, because there are interfaces in here as well. I'm gonna read up on here more because we're saying, let's a tuple struct here. A struct of point 2D with two integers of 32 bits, and then a unit struct called struct unique. They are used in C. C structs are the most commonly used. Each field defined within them has a name and a type. After they are defined, they can be accessed by using example struct.field. Tuple structs are similar to classic structs, but their fields have no name. That makes sense because tuple you have to access it by index, but I'm kind of curious, if you already have a tuple, why would you have it in a struct? Or maybe they mean example struct dot field dot zero. I'm not sure. Unit structs are the most commonly used as markers. We'll learn more why these might be useful when we learn about Rust traits feature. Let's instantiate a struct. To use a struct after we've defined it, we create an instance of the struct by specifying concrete values. We're creating a person struct with these values for those properties. We're creating a tuple struct of a point starting off at 0, 0, and initiate a unit struct. This is tuple syntax. That makes sense. Then we'd have to say origin.0 would give us 0, and origin.1 would give us the second value in the tuple, which happens to be 0, 2. We have the person struct, the point, and the struct unit. This is what they showed in the example. And then we say let person equals, and they mentioned this before, you do string from, and I'm not sure why you wouldn't just do, for example, this. Let's run this. It's going to complain about not using the things. I had to add a semicolon there. Let's run that. Should execute, and I think I saw in the previous ones it said they're not being used. So far, I'm really liking that it's pretty explicit, the errors. I think that's super handy. I'm looking at you. Undefined is not a function. I'm curious if we do print ln person, then we do this, and we do person. I wonder, because the struct appears to be a complex object of sorts, I wonder if it's able to print that out. or do I have to do something like print out each property? Just curious to see what it's going to do. So let's go origin. Unit. I have no idea what that is when its default value is just unit, but let's see. Let's run that. Expected one. Okay, print person. Yeah, it looks like you can't just print out the whole object, which I thought would happen. Let's see if we do name. Person's name. Let's run that. Wonder what I'm doing wrong there. Source main 25. It's complaining later on. I'm so used to Prettier putting in these things, whether you have semicolons defined or not in your config. All right, let's run that again. Any kind of complex object, it can't just print it like that, which I think is fair. Let's just comment that out. And then we should be able to print out the person's name. Maybe the compiler complained because you're, yeah, unused variables. We need to definitely do something if you want to two-string these things, which I think makes sense. Enums are types that can be any one of several variants. They're commonly known as algebraic data types. The enum keyword allows the creation of a type, which might be one of a few different variants. Enum variants, just like structs, can have field names, fields without names, or no fields at all. In the following example, we define an enum to classify a web event. At this point, kind of wondering, at least in Rust land, there's a bunch of different data types. Curious to see what they recommend using what for when. Here, called web event, there's page load, page unload. This looks like a function. If you do a key press and it takes in a character, that looks like a function signature. Paste, same thing. Click, which is a tuple struct. It has 4 variants with different types. There's no data associated. I'm pretty sure that's kind of just handy. If you have a web event, you can say the web event.page load. You don't even need to, it's not even a Boolean. Defining an enum with variants such as a proceeding is similar to different kinds of struct definitions. All the variants are grouped together under the same web event. Each variant is not its own type. This means that we can't have functions that only accept key press and not other variants of the web event enum. That makes sense because they appear to be mandatory. We can choose to define separate structs for each variant and then have each variant hold on to the different structs. These would hold the same data that the preceding enum variants held. But this definition would allow users to refer to each logical variant on its own. Let's see how this plays out. So we have an enum with these, I don't know if property is the proper term, but there's a struct called click and a struct called key press char. At this point, until I read in a bit more, I'm looking at this, for example, like struct key press char. To me, that looks like a function signature. I guess it's not fn key press char because that would mean an actual function. Maybe struct key press is a way to write the function signature, but I'm not sure yet. Now in your code, you can refer to a web event click, which is a variant of the type web event. You can also refer to click on its own as a separate web event. Next unit, exercise. Fix the code with structs and enums. Let's see here. Edit only car factory function so that it can return car objects as requested by the clients. All right. Replace this with an actual, oh, that's interesting. That macro seems interesting. Like, hey, you need to do this code. Interesting. Let's look at the car. It's got these properties. I'm just trying to remember how you do this. Let's copy this. Let's go to the playground. Paste it kind of weird. Function main. And we need to put in a car. Let's put in here. Let's see, color. Say aqua blue, sure. Transmission. Let's go manual. I am not a car person, but I drove manual cars for quite a while. Convertible, false, because I live somewhere where we get winter. Mileage, we'll say 600. I'm going to assume it's kilometers, but it very well may be miles. Let's run that. I don't know if I define this properly or not. I'm not sure if I have to say car here or what, but we'll find out. Struct literal body without path. Maybe I have to do something like this. I'll go check in the notes in the previous module if not. Expected. What line is it complaining about here? Line 21. Oh, you know what? I need a semicolon. I'm pretty sure once we get into VS Code land, it should be doing this automatically, hopefully with the semicolons, because if not, I am going to mismatch types, aqua blue, expected struct string, found ampersand string. I'm not sure why I can't do that, but I guess I have to do the string from. Let's try that. It takes two. This looks like the syntax for calling a method on something. The two colons. The transmission manual. Same thing again here. Hopefully we're in good shape now. Feeling hopeful. Mismatch types. Expected enum transmission found structure. I didn't realize that that was a, oh yeah, I should have seen that. It's transmission. Just go dot manual. Let's run that. Still got some compilation errors. The num is defined here. Again, I gotta say I'm pretty impressed with the error messages because it tells you exactly where to go. Line 9 is where it's defined. And I guess maybe with enums in Rust, you don't need to actually put the name at the beginning. Or if it's not that, maybe I have to use the double colon. We'll see in a sec here. Gonna take a stab here and see if it's this. If that's not it, I'm just gonna go look at how you run the enum. Unused variable color. It looked like it compiled. I got some warnings. Let's look at this again. It looks like you have to, when you're instantiating or creating a struct, you have to put the name of the struct, curly boys, and then you put in the properties and values that correspond to their types. When you're calling methods on, I don't know if these are considered classes, well, the enum's not a class, it's an enum, but I don't know if the string type is considered a class in the language or what, but this is how you seem to invoke methods on things. That's why I'm thinking it is a class, but maybe not. We fixed the car part. The solution to this exercise is here. Let's go see what they did. I'll try loading it again. Oh, interesting. Their playground loads it from a gist. Interesting. Let's try this again. Okay. It's not loading up. I don't know why, but we saw when we did it, if I go back to my example here, where was it? I lost what I had worked on, but we just went through it and explained what we did here. So that's good. Next, create reusable functionality with functions. Functions are the primary way code is executed within Rust. The main function is the entry point of many programs. Functions are defined by fn and have a set of parentheses after the function name. That seems pretty standard. Braces tell the compiler where the body of the function is and begins and ends. I was calling the function probably before, but I was calling it outside of main. Maybe that's why it was giving me compilation errors. If I come here, run this, it should print hello world and hello from another function. That's expected. Function be called by entering its name. That's just explaining what we just did. We can pass parameters. We're saying is divisible by is a function. The dividend is an int32. The divisor's an int32. We're just saying whether it is divisible or not. Let's do that. It's divisible by. So divisible by. Let's say 9 is divisible by 2. And we'll say let. This returns a Boolean. I'm assuming it'll be able to infer it is divisible. I don't think I need to explicitly say bool here. And we could do print ln is 9 divisible by 2. And let's put our curly boys. Right is divisible. And got to put my semicolon. I got a char here. There's some color syntax highlighting showing me that's not right. Is 9 divisible by 2, and then the Boolean value should pop in there. Let's run that. One other thing to note, it doesn't look like it matters where you define the function. Seems to be taking a while. There we go. Is 9 divisible by 2? No, of course not. But if we say 3, we should get true. Let's run that. It's true. Thank you, math. Now, is divisible by function accepts 2 integers as inputs and outputs, a Boolean value. No, let's take a look closer at the function body. The divisor equals 0. Let's see where that's at. If divisor equals 0 here, you definitely don't want to do equals because that's trying to set it to 0. Here, double, and notice we don't need to use parentheses in the if, I guess. What we're saying is the divisor equal to 0 when 9 divided by 2 is done. Wait, oh wait, sorry, this is the base case. So if the divisor equals 0, we return false immediately. Otherwise, is it divisible by the divisor? Yeah, the division by 0 error. We still haven't covered conditional expressions yet, but this snippet is simple. If checks if the divisor is 0, returns false if it is, otherwise continues. In Rust, the last expression inside a code block is always returned. So we don't need to use the return keyword in here. I think Ruby does that as well. I saw that because at forum, the backends in Rails, and I think the first time I saw that, I was like, I didn't realize it was trying to, that it was returning something. That makes sense. If it's the last line, it makes sense. I'm guessing you can do an explicit return, but it's just really not necessary. I wonder even if Maybe you'd have a linter rule for that, or maybe the Rust linter does that. If there is a Rust linter, I think that's Rust Analyzer, which runs the language service. It doesn't complain about it, but you don't need it. All this part of the function is trying to do is prevent classic programming error. Let's see our function in action. We did that. We can do that. That's good. If I do false here, even though 24 is divisible by 6, that should pop me an error in the compiler. Left true, right false. That's good. Let's see, can interact with the preceding example. Yeah, we did that. We can learn about how Rust works when we break things on purpose. Let's try and return char instead. Char obviously does not map to a Boolean here. It should give us a compilation error saying, hey, you didn't return a char, or you should be returning a Boolean. I'm assuming it's saying you didn't return a char. Yeah, expected char because of return type. If we put it back to bool. The other thing I wonder is if you don't specify the type. I think if all code paths return the same type, I would guess it would infer it as Boolean. Try adding a return type. So far, I think my favorite part of Rust is the error messages. It's telling me literally what to do or giving me really good hints. I'll put it back to Boolean. We'll know this will run. Collection types. I'll go pause here for today. We're going to continue on collection types next time. Thanks, everybody. Hopefully, you'll come by next Friday too, 5 p.m. UTC every Friday. We're learning Rust. See you later.